up, Arnie, my boy? You look puzzled.
Oh, it's a surprise more than a puzzle, Tech. Bob told me only last week about the new distributor that Chrysler Corporation is making. I think one of them just came in on this car I'm getting ready for delivery.
Boy, that's quick. Did you hear that, Bob?
I heard it, Tech, and it's good news. Now we can take a little time to cover some of the things that are different and talk about how this new distributor works.
Uh-oh. Sounds like a lot of changes.
Not as many as I think you got in mind, my boy. Just enough to keep things interesting. At the present time, you'll find this distributor on only certain V8 engines. Later on, when production capacities can be increased, it'll be used on other engines. Let's get this one out of the engine and over to the bench. Then we can take a closer look at the differences and put it through some of its paces on the distributor tester.
Okay, Bob. I'll have it out in a couple of shakes. I noticed that this hold-down clamp is a little different, Tech. And the whole distributor sure feels a lot lighter.
It certainly should. It's just about half the weight.
Good point, Tech. Those reinforcing ribs on the new aluminum housing also serve as a good identification. You certainly can tell the new distributor from the old one. Inside the rib section, the shaft is fitted in oilite bushings, which are pressed into the housing. The upper breaker plate on which the contact points and condenser are mounted slides on bronze bearing supports in the lower plate.
Anything new about the cap?
Yep. The center carbon contact is now staked in a fixed position in the terminal insert. It isn't spring-loaded as before and doesn't have a resistor. Instead, resistance is controlled by the new type high-tension coil cable marked radio. Spring action, formerly in the center terminal, is incorporated in the new rotor assembly. Let me show you. See this spring steel contact arm? It's held against the center carbon contact when the cap's in place. The electrode is attached to the arm and body by a spun-over eyelet.
I see something else, too. There's a driving lug molded inside the rotor body. It slides into that slot in the top of the cam and does the same job the flat surface does in other rotors.
Right. And the distributor cap has an indexing cutout in the lower rim. It fits over a tab on the vacuum control assembly to help position the cap properly.
Just full of improvements, huh?
You said it. One of the important changes is that the breaker contact assembly comes as a unit. It consists of the movable point and the stationary point and insulator. A sleeve at one end of the adjustable bracket fits over and pivots on a mounting pin located on the upper breaker plate. This sleeve also serves as the pivot for the movable contact arm. The stationary contact point is on the opposite end of the adjustable bracket. A vertical U-shaped tab in the center supports the contact insulator.
And that movable point arm has a new nylon rubbing block.
You're so right. It's lighter, stronger, and less apt to expand or contract due to temperature changes. Besides that, the contact area has a brand new design. Two troughs formed by tiny ridges are on each side of the contact surface. These troughs keep lubricant on the cam where it belongs. As a result, there's less rubbing block wear and less point gap changing. Also, the lubricant can't spray around inside and get on the points, causing them to burn.
The lightness of that nylon block has another advantage. It provides a lighter contact assembly. This reduces contact point bounce at high engine speeds. That means full dwell, saving in fuel and better performance.
Pretty neat idea, I see. How about the breaker plate assembly?
Why, that's still an upper rotating plate and a lower stationary plate. Two screws hold the lower plate to the housing. Both plates are held together under spring tension to prevent chatter. A Y-shaped spring attached under the lower plate by a pivot pin supplies the tension.
I get it. Are the weights different?
Somewhat. The weights now are one piece and zinc die-cast instead of laminated steel construction. And oilite bushings pressed in the large end allow smooth pivoting operation. The centrifugal advance mechanism is made up of an advance plate attached to the upper end of the shaft, two weights, and two weight springs. A pin on top of each weight operates in the cam yoke slot to control outward swing. A coil spring is attached to the inside edge of the small end of each weight. The springs are of different tensions and control how fast the weights swing outward. The light spring controls advance for low-speed operation. The heavier spring controls high-speed advance.
Those spring tensions adjustable?
Yep, and by using a screwdriver through an access hole in the lower plate. Bending the lugs inward decreases spring tension. Outward increases tension.
Good, I like that.
Sparking inside the distributor creates ozone, as you know. When it combines with moisture, the parts will corrode. Drain holes in the housing floor let condensation escape to prevent corrosion and ventilate the unit.
In other words, don't let them get plugged up.
That's the idea, Arnie. Now, the vacuum control assembly is a precision preset unit and is sealed when it's made. It's not adjustable as it once was.
Attaboy, Tech. Good point. We've covered some of the differences in construction so far. Suppose we talk about how it works. That'll help us review the part played by the distributor in overall engine performance. Later, we can talk about some tests. Basically, the distributor interrupts current to the primary coil windings to produce high voltage at the plugs. Its second job is to distribute this voltage at the right time according to piston position, speed, and load. You know, of course, that high voltage is created in the secondary circuit as the cam lobe opens the contact points. This breaks the primary circuit. The magnetic field in the coil collapses quickly. This rapid change creates a high voltage in the secondary, enough to jump the spark plug gaps. And as the open points cut off the primary circuit, it flows into the condenser.
Yeah, and if it weren't for the condenser, current flowing when the points separate would arc and cause burning. The magnetic field also would collapse slowly instead of quickly as required.
Right, Arnie. That condenser does a mighty important job. Now, besides building up high voltage necessary for good ignition, the distributor has a vital timing job to do. For example, you know that combustion must be completed by the time the piston has moved downward about 20 to 25 degrees of crankshaft rotation. Therefore, the spark must take place far enough in advance of that position to allow time for the mixture to burn. A spark too far ahead of top center will create combustion pressure before the piston can start down on its power stroke. Piston travel will be retarded, and you'll probably hear a knock.
Yeah, and a spark after top center will create combustion pressure too late. The piston will be too far down on its power stroke, so much of the power will be wasted.
Besides wasted power, oil on the cylinder walls might burn off, and the rings and walls will wear faster.
Well, you don't have to sell me on proper timing. I know it's mighty important.
Swell. Then you know that the distributor, mechanical, and vacuum advance features are needed to help vary timing automatically to meet all operating conditions.
Before you go any farther, Bob, let's flip this record. There's no room for any advance on this side.
The mechanical advance, consisting of two centrifugal weights, drives the cam, which opens and closes the points as the distributor shaft rotates. The springs control the rate of outward movement of the weights. As the weights swing outward, they move the cam in direction of shaft rotation. This makes the lobes meet the rubbing block sooner, advancing engine timing.
As engine speed slows down, centrifugal force isn't great enough to overcome spring tension. So the springs return the weights to no advance position.
I get it. But let me ask this. When does the vacuum advance come in?
During a light load part throttle condition. Engine vacuum then is fairly high.
I see. Now, can you give me a rundown on how the unit works?
Yep. It's a sealed unit with a vacuum diaphragm and spring. An arm connected to the diaphragm is also connected to the upper breaker plate that carries the points. Vacuum comes through a tube connected between the vacuum chamber and a port in the carburetor throttle body. That port, as you may know, is above the throttle valve. When the valve is closed, there's no vacuum at the port. Since no vacuum will reach the diaphragm, the breaker plate won't move. When the valve opens, the port is open to manifold vacuum. That draws the diaphragm against spring pressure, pulls the arm, and moves the breaker plate in a direction opposite to cam rotation. The rubbing block meets the cam lobe sooner, advancing the timing. As the throttle opens wider, vacuum falls off at the port. Spring tension pushes the diaphragm back and moves the breaker plate in direction of cam rotation to retard timing. That prevents knocking due to timing being advanced too far for throttle opening and engine load.
Very clear, Bob. Now I've got a question. What should I watch out for in regard to maintenance on this new distributor?
The usual periodic precautions, Arnie, like regular lubrication, cleanliness, and good connections. Also, you should know what tests and corrections to make when the engine's not up to par.
Let's take those in that order. Every 1,000 miles, for instance, put 5 to 10 drops of light engine oil in the oiler. That's to lubricate the shaft bearings. At the same time, wipe the cap clean. Oil, grease, or moisture between the terminals may cause cross-firing. Check the cables for firm seating in the terminals. Incidentally, remember to remove cables by pulling them straight out of the towers. Yanking them out can stretch the conducting material and increase cable resistance.
Okay, I'll watch that.
Good. Every 10,000 miles, remove the cap and rotor. Put 2 or 3 drops of light engine oil on the felt wick in the top of the cam.
Just a couple of drops, Arnie. Don't over-oil that wick.
Tech's right. And lubricate the cam just as carefully. First, wipe it clean. Then, with a light coat of approved cam lubricant on your finger, hold it against the cam and turn the shaft to get an even film on all surfaces. Over-lubrication will splatter around inside and cause the points to burn.
All right. Now, how about the points?
Examine them, of course. If they're just frosty gray, they're okay. But if they're badly pitted or badly discolored, replace them.
Always check the condenser capacity, resistance, and leakage on a tester. 0.25 to 0.285 microfarads is the correct capacity range.
Okay, I'll keep it in mind.
To replace the points, you must remove the distributor and clamp it in a vise. And here's good news. Point assemblies come pre-aligned and with spring tension pre-adjusted. Just remove the old, install the new, and set the gap to specifications.
Say, that's all right.
Here's a tip, Arnie. Use a narrow blade screwdriver when you install the points. A wide blade will bend that pre-aligned contact arm. And don't let the screwdriver slip either.
And don't disturb the inner nut on the insulator screw. It secures spring tension. If the nut's loosened, you'll have to check and maybe readjust spring tension.
While you're at that point, Bob, remember that the condenser lead and primary lead clips go between the two nuts, with the condenser lead on the inside. Just an installation fine point.
I get the difference. Okay.
After you install the points, always see that the gap is 15 to 18 thousandths. Spring tension is 17 to 20 ounces, and cam dwell is 27 to 32 degrees.
But I thought they came all set and didn't need to be checked.
Don't take anything for granted, my boy. It's good practice to be sure. Remember the slogan, it's wrong unless it's double-checked.
Well, okay, if you fellas say so.
We say so, Arnie. Use a flat feeler gauge or a dial indicator to check new points. Always use a dial indicator to check the gap on used points. And don't forget to clean the points. Draw a piece of linen tape between them to remove any dirt, oil, or perspiration from handling. Actually, you should never touch the points. Foreign matter on them will make them burn.
Okay, Bob, I'll keep them clean.
Good. Now, when you check spring tension, hook the scale over the arm just inside the contact point. Pull at right angles to the contact surface. Take your reading just as the points separate or as your test light indicates.
How can that spring be adjusted if necessary?
By loosening these nuts, Arnie. Slide the spring in or out as needed. Tighten the nuts and recheck tension. When you check dwell, remember to mount the distributor lower in the tester. There's a slight taper on the lower end of the housing, so you'll have to clamp around the rib section. But not too tightly, mind you.
Firm, but not enough to crush the ribs.
Correct, Arnie. Now, check dwell with no vacuum applied at idle speed, as well as at 2,000 RPM. There shouldn't be more than 2 degrees variation.
Right, Tech. And besides that, check dwell with vacuum applied at idle and 2,000 RPM. There shouldn't be more than 8 degrees variation with vacuum connected. If you do find too much dwell variation, look for one or a combination of these causes. Worn rubbing block not square with a cam, a worn breaker plate assembly, or wear on the distributor shaft and bushings. You should use a dial indicator to check further on the cause of variation in dwell. Remove the cam, breaker plate assembly, and centrifugal advance mechanism from the distributor. Then, secure the body and shaft in a vise and attach the dial indicator. Move the shaft to and from the indicator with just enough pressure to measure movement. Too much pressure will spring the shaft and cause a false reading. If there's more than 8/1000ths total movement, replace the shaft and the bushings.
Very clear, Bob. Any further tips?
Yep, there's more you ought to know on checking advance characteristics, mechanical and vacuum. Also, some handy tips on setting ignition timing. But you'll find it covered completely in this reference book.
Good deal, Bob. That book's going to help me a lot.
Look over the section that explains what we've just talked about, too, Arnie. And right after we break for a few minutes, it'll be smart to review what we've just learned about this new distributor. We'll soon be seeing a lot of them.